Welcome. This is a video recording of the version control talk we had on March 8th. This is going to be pretty much the same talk, just tightened up a bit and with better audio. Let's do it. So version control, well, what is it? Here's a definition from the Git SCM website. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. Pretty much hits the nail on the head. Another definition that I would give that might be a little simpler is version control is a system for backing up your work and collaborating with others. And that's pretty much why we use it, to save work that we've done more reliably, to collaborate with others easier, to experiment easier because our work is backed up, and to keep track of our changes over time so we can know what happened when. So what about not using version control? What about using something else like Dropbox or Google Drive? Well, it's important to understand the differences between systems like that. In Dropbox and Google Drive, for example, you don't have a version control system. What you have is a file syncing system. So there are no explicit commits. Rather, every time you save a file, it gets synced, and that may not necessarily be what you want. In a version control system, you get to commit a file when you decide you want the file to be added to the repository, because maybe not every time you save a file you're introducing a change that is beneficial or that works or is really what you're going for. So it's really better when you can decide what's going to go into the history rather than everything going into the history. Also, there's no merging. So new changes to a file are just going to clobber old changes to it. So there isn't really a good way for more than one person to work in the same file. If you want to merge that stuff, it's going to happen manually. Whereas in a version control system, you can have text files merged automatically by the version control system you're using. What about using an external hard drive, though? Well, that's something that could work out for you if you're at a game jam or something, where it's just something you're throwing together quickly over a couple days with a really small team, but it's pretty clearly cumbersome and it's not going to scale well. So for anything that is bigger than a game jam, I wouldn't really recommend it as a viable backup solution. You could also just not care and not do any version control. I think this is what a lot of people do, but frankly, it's a lot less safe. Your work isn't backed up very reliably, which can be a significant risk if you're working in any kind of professional capacity, or if you just care about the work you're doing and you want to keep it around. Also, you have less freedom to experiment when you're not using a version control system, because you need to be more careful about maintaining a stable build of your game. So this is the basic version control flow with some updates for Git. And there's pretty much three things you do in a version control system. You add files, you edit files, and you delete files. After you make a change like this, you commit them to your repository and they're saved in its history. A repository contains a history or multiple histories of different versions of your files. Now in Git, there's an extra step in the version control flow that you won't find in a version control system like SVN, and that's called staging. In Git, you have to stage a file before it's committed, and arguably this extra step makes the decisions you're making much more deliberate, because you have to explicitly stage a file before you commit it, rather than the file being eligible to be committed just because it's in one of these states: added, edited, or new. Also, there are two other things you do in a version control system, but they're pretty much just combinations and aliases of the core three. So renaming a file under the hood is the same as a delete plus an add. You're deleting the old file and you're adding a copy of it with a different name. And a move is the same thing as a rename. So Git, what is that? Well, Git is a very popular distributed version control system. Distributed meaning everyone gets their own copy of a repository. Git is originally a command line tool. There are GUIs for it. GitHub has an app, there's SourceTree, which we'll be using, there's Git GUI, there's a number of others. Git is designed for programmers, and it's really meant for code, and by that I mean text files. So why do we use it? Well, we use Git because it is very, very powerful. It gives us a lot of fine-grained control over how things are tracked in our repositories. It's also really great at branching compared to some other version control systems, which makes it a lot easier to experiment with a project. Also, the fact that it's distributed is really great, because since everyone has their own copy of the repository, you can do things like work offline without an internet connection, and you still get the benefits of having version control, committing, resetting commits, branching, etc., without needing to connect to a central server. So it's easier for you to work independently, and it's easier for a project to evolve in different ways if each person can have their own repository. It's also very popular, which matters. There are a lot of great tools and services built around it, such as GitHub and SourceTree. And since so many people are using Git, if you have a question about how something works, if you Google it, it's probably been asked and answered already. Now, SourceTree. The reason that I've chosen SourceTree is that I want this tutorial to be pretty accessible. Now, when I use Git myself, I prefer to use the command line, but I know not everybody is comfortable with it, so I decided to use a GUI. And I chose SourceTree for a couple reasons. One reason is that it's free. You don't have to pay anything, but you do need to create an account with Atlassian. They're the company that makes Jira, so if you have a Jira account, you might already have an Atlassian account. It has Windows and Mac support, so it's cross-platform in that regard. It's also really popular, similar to Git, so if you have any questions about it, you can just Google it and someone's probably answered it already. It also helps that I'm familiar with it if I'm going to be talking about it. But also, as opposed to the other Git GUIs that I've used, like the GitHub app and Git GUI, I find that SourceTree provides a really close correlation between the command line and the interface. And I think that's really great because ultimately I want you guys to understand how Git works more so than how any particular program works. And in my opinion, using SourceTree will give you a better sense of what's going on under the hood as opposed to using something like the GitHub app. Alright, and then there's Unity. And Unity is a super duper popular game engine. It's a really great game engine and a lot of people are using it. And it has some particular quirks when working with Git and with version control. I'm going to point some of those out. Some of the things I'm talking about with Git can be applied to any software you're using, and some of these are going to be very Unity specific. So let's get to it. Alright, so I've broken this up into a number of scenarios. The first scenario is going to be starting a new project working by yourself. This can also be thought of as adding Git to an existing Unity project, but the way we're going to run through it, we're also going to create a new project at the same time we create a new repository. So let's get started. So let's go ahead and create our Unity project. Launch Unity. And I'll make a new project. It can be there. Let's go ahead and call this VC Talk. Get loaded up. Alright, nice. And let's go ahead and open up SourceTree as well. Alright, so this is SourceTree. I'll be going over, the UI is, we use different parts of the functionality. And the first thing we're going to want to do is to create a new repository for our project. So go ahead and click this button here, Clone New. And on the right, choose Create New Repository. It'll be Git by default. Choose the repository location, and then what we want to do is choose the root folder for our Unity project. So that's the folder that contains assets and project settings. So it's the folder we just created. This is where we want our Git folder to be. Select it. You can change the name for it if you want. Go ahead and create. That's getting created. I will show it to you in the file system. And you know it's been created because it creates this .git folder. It's actually a hidden folder because it starts with a dot. So if you don't have hidden folders shown, you're not going to see it. But if you do have hidden folders shown, then your Git repository is going to have a .git folder in there, and that is where the magic happens. So alright, we're back in SourceTree, and now we got some stuff on the screen. So first of all, on the left side, we have the Bookmarks tab. And the Bookmarks tab is going to show us how many repos we have active in SourceTree that we can switch between. We only have one repo right now. We're going to have another one later, but for now we don't really need to look at it, so we can toggle it with Control B or go up to View, Show Hide Repo. Another thing in the Bookmarks view, it's just going to give you a quick glance of the pending changes that you have right now. So here we have 94 untracked files. That's what this question mark means, untracked. and we can see them here in the unstaged files area. So like I was saying before, in Git you have to stage a file before you commit it. Right now we don't have any files staged, but these are all the files that are eligible. And there's quite a lot of them. We have some default views for our files. Right now these are pending files, so these are things that can be committed to our repository, files that are added, or files that are untracked and that we can add. If we had some files in our repository already and they were edited, they would appear here. And if we had some files that were deleted, they would also appear here. We can change the filter by choosing clean, for example. This would show us everything in our repository. There's nothing in there now, so it's empty. We can go ahead and choose untracked, and that is everything right now because we haven't added anything to our repository. Let's keep it pending. There's also some different views here. We can split this up into 2 columns, so it'll just have the file name and then the path to it. I prefer to do the single column. And also, the way that SourceTree in Windows is right now, it lists every single file. So there's no way to really combine these by folder. There is an option to do that in Mac. There's something called Tree View. But in Windows, if you wanted to select every file in a folder, you'd literally have to like shift and select all of those files. So just wanted to point that out. So this is the unstaged files. This is the staging area. On the right, this will show us our diffs. Now a lot of these we're not going to see diffs for because they're binary files, and SourceTree is not going to show us diffs for binary files. But whenever we have a text file, it's going to show the diffs between the previous version and the current version of it. And if you're adding a new file, the diff is just going to show the entire file. So let's see. How about we add this stuff to our repo, but not all of it. We're not going to want to add all of this stuff. And the reason is some of this is Unity specific and it's not something that we're going to need to track. So specifically, the library and the temp folder are 2 things that Unity creates, and they work as sort of a local cache. So whenever you run a scene or you move things around in Unity, the way Unity is able to do some of that stuff so quickly is it caches a lot of files that it uses internally, and it keeps those in the library and temp folder. Now you don't want to keep these because they're unique to your machine, so they're not necessarily going to work on another machine or another person's machine. Also, they're huge. They take up a lot of space and they change all the time because they're binary files, so they can't really be merged. So they're going to bloat the size of your repository, which isn't something we want to do, especially if we're using a hosting service, which we're going to be using later, and they have limits for the size of your repository. And most importantly, these aren't files that we really need to keep track of to run our repository. Once you clone a project, they're going to get created. They're going to get created by Unity the first time you run it, and then you're pretty much good to go. So to exclude these from our project, we're going to use a git ignore file. There's actually a pretty good one right here. It's actually provided by GitHub, which is pretty rad. So again, that speaks to how popular Git and Unity are. Because I believe, look, I'd already searched for it. If you Google Unity git ignore file, and this is the top result you get. So that is pretty great. And in this ignore file, you can see right at the top we have library and temp, because we don't want those. We have OBJ, which can get generated when you make a build sometime, and you don't necessarily want to keep your builds in version control like this. The builds folder, asset store tools, and also some paths here for files that can get created by your Visual Studio or mono developed solution. So this looks pretty great. Let's go ahead and get this file. I'm going to choose the raw, and we're going to save it. And we're going to save it right in the location of our project, where we are right here. And we want to save this as just .gitignore. The name needs to be exact. And also, this is important, do not save it as a txt file. It needs to just be a gitignore file. So save that there. And let's take a look at it in the file system. There it is. Alright, now let's go back to SourceTree. Alright, give that a sec to update. We can also hit F5 to refresh, or I believe go up to view and refresh. Sometimes SourceTree will make you wait a bit, so it's best to refresh. Hopefully it won't be too bad for me because I'm also recording this as I'm doing it, but we'll see. Alright, so here's our gitignore file. This is everything that's in it. And now, you may not have noticed, but the library and temp folders are gone. So all that stuff is gone. If you look at the bookmarks, oh, actually that didn't update, but yeah, there's way less stuff here that's going to get added. So that is pretty good. We're almost ready to do our first commit, but I also wanted to point out that, I don't know if you've noticed, but the assets folder also isn't getting included. We have the assets folder here. We have it in Unity as well. Assets. But the reason it's not included is because there's nothing in it. And by default, Git is not going to include an empty folder. So let's go ahead and put something in it. We can save this blank scene as default. Just call it main scene. Save that. Go back to source tree. Let this refresh. Alright. So now we have the main scene. We got a meta file for it, which I'll go over in a second. And now we're ready to do our first commit. So to commit these files, first we want to add them. There's a couple ways to do that. You can just right click and choose add. You can shift click a bunch. In this case, we definitely want to add all of our files. You don't always have to commit everything that's in the unstaging area, but we're ready to do that. So you can just click the arrow there and it'll pull everything up there. And then just include a message. Say initial commit of our repo. And choose commit. Alright. So now, if we looked at clean files, we would see that we have everything that we've just committed to our repo. We can check out ignored files. That's everything in the library and in temp. And pending files. We don't have anything because our repo is clean right now. And also, this appeared under branches. So this section here, these are some different views for our repository. So the working copy, that just refers to the folder in your file system where your Git repo is. So the working copy is where everything lives. Now branches, these are the different histories in your project. And by default, the main branch, or the main history in your project is called master. And anyone coming from SVN, master is just the same as trunk. So right now we only have one commit in it, and here it is. And these are the files that changed. These are, the diffs for them. That one's binary. This was our commit message. This is the unique commit ID. Here's the date and time. Here's the author. So there's a whole lot of info here. Every commit gets a unique ID for it. Looks like source tree even generates a unique image based off of this ID's hash. The description kicks in if the commit message is a certain length, I believe. So if this had been longer, I think the rest of it would have just become the description. And yeah, there's another way to look at this view. You can get it by selecting the name of the branch under branches. You can also go down here and choose log history. And same with the working copy where the pending changes are. You can go to working copy. And I'll give that a sec to switch over. Working copy. Or you can go down to file status. So there's just a couple ways to see similar views here. And the rest of this, tags and remotes, we'll get to that stuff later. Alright. Alright, so let's talk about metafiles. So the number one thing to mention about metafiles, I suppose, is that they can be hidden or visible. Now by default, I believe that Unity hides them. And by default, I believe Windows and OS X hide or don't show hidden files. Now I have it so that hidden files are visible. If you don't, you might not even realize that the metafiles are there. So you can either toggle hidden files to definitely see it, or you can change the settings in Unity by going to Edit, Project Settings, Editor, and then change your metafile mode to visible, and it'll always be there. I like mine to be hidden, just because I see hidden files anyway, and I like that it has that semi-transparency. Now if we look over what's inside the meta file, we can see it just has some information about the scene. Here's a unique ID for it, here's the time it was created, there's a license type of Unity that I'm using, and if it had an asset bundle name, that would be here as well. And that's all good. But let's see what type of meta file we could get for something a little more interesting. Let's go ahead and add a model. Alright, so we got a robot model, add it to our scene. Let's move this back to, and turn it around. Alright, great. Let's go ahead and commit this. Hit 5 and give source tree a sec for the new stuff to pop in. Alright, so we edited our scene. I can't see it because the scene's binary. We added our robot model. We added materials for the robot. There's also a meta file created for the folder. Now that is something that is Unity specific. Every file in our assets folder is going to get a meta file. Assets won't get a meta file, but the scene will, the robot will, the folder will, and the material will. So again, just keep that in mind. Everything gets a meta file, even folders. We want to add all this stuff, so we can just click this checkbox here. Let that all pop up. For our commit message, we'll just say added robot to project. And also, we can just hit Control and Enter here to commit. It's a little keyboard shortcut. So now that we have this robot in the project, let's put something else in the scene so we have a little bit of perspective for it. Let's just add an empty box. Alright. Let's not put it there. Let's have it about next to this guy. Alright, that's cool. So now we have our robot, now we have this box. And we can see about how big the robot is. Let's go ahead and commit that as well. Scene just changed. Added box to scene. Alright. Now our robot's meta file has a lot more information in it than our scene meta file. And a lot of this has to do with the import settings for the robot model. So, whoops, let's not do that. I'll revert that. So, let's say we wanted to update our import settings. Like, let's say we didn't want our robot to get imported at this size. And we also don't want our robot to come in with normals. We just want it to look a certain way. Apply that. Alright, now we see our robot is definitely shorter. Also got this kind of almost like a ghostly look to it. That's cool. Let's go ahead and save the scene and take a look at it in source tree. Check out working copy. Alright, now we can see that some changes have been applied to our meta file, and here they are. So the scale has been changed and some of the import modes have been changed. So that's another thing that meta files do. They keep track of the import settings for your models and your textures and things like that. So let's go ahead and commit this stuff. So this is a Unity specific thing about version control, and I suppose just generally about working with Unity, and that's you want to make sure to keep meta files close to their original files, or else you're going to lose the data in them, and you might and if you lose the data in them, you're going to lose whatever data was associated with that model or texture or whatever was associated with the meta file. So I believe it's in the Unity docs that they tell you that whenever you're moving files around, it's better to do it in Unity than in the file system, just to make sure the meta file is automatically taken care of. And let's just show an example of that. So I wanted to organize this a bit. create a models folder. And I wanted to put my robot in the models folder. So that seems fine. You know, looks the same in the scene. I go over to it, I see the robot there, select it. Import settings look like how they changed. The scale factor's down, no normals. That's fine. Let's say I change my mind and I want to have the robot model back in the assets folder. So I move it back in Unity and everything seems fine again. Robot's in the scene. Select the robot. Import settings the way I left them. That's fine too. Seems pretty unremarkable. Well, let's say that, for example, I moved the robot in the file system. And this could be an easy mistake to make if you have the default settings where hidden files are not shown and meta files are hidden. Now let's say I just move the robot to the models folder while ignoring the meta file. The robot's gone. Now what's going on? I look over here. Okay, it says it's missing. Well, I know it's right here. Maybe I can just fix it. Drag an avatar back into it. It says it's missing an animator controller. Can I do that? No. Oh, shucks. Alright, well, let me grab a new robot. Oh, it's all the way over there. Well, I can copy the transform of the previous robot. Paste it here. Alright, the robot's back, but looks different. Yeah, it's too big. And the normals, it doesn't have that ghostly look anymore. Well, the reason's because what happened is our import settings got lost because Unity created a new default meta file because our old one lost track of the file it was associated with. If we take a look at it in source tree, we're going to see that as well. It shows that our original meta file has been deleted, and now Unity has created another meta file for this new file. But since it didn't recognize that we were moving this file, it just assumed that this is just a brand new file. Now, this is also something that I mentioned before. These files were moved as far as Git was concerned, but under the hood, a move is treated like a delete and an add. Go ahead and save the scene. The scene was edited. Now, if I go ahead and stage all of this stuff, right, the deletes and adds turn into a rename, so the rename is the same as a move. And if we look at the diffs on the meta file, we can see that the GUI ID changed because it's a different meta file and the time created. So now this is a different file from our old one, and that's why that the scale and the import modes were reset as well, because we moved it in the file system without the meta file. So Unity deleted the old meta file and created a new one, but to Git it looks like we're moving it. And it is a similar effect to moving it, but since we moved it in the file system, we lost the changes that we wanted to include. So let's not commit this stuff. Let's go ahead and discard it. We can do that by choosing discard, and this will select all the files in our staging area, the box next to pending up there. Discard these changes. Okay. So now we have to reload the scene because it was changed on disk. And it's looking better right now. Alright, so now let's talk about resetting changes. So what we just did is we discarded some changes, and that's another helpful thing that we can do with Git, is if we don't like the current state of our project, we can just reset it to the last time we commit. So let's take a look at some other ways to do that. We're going to talk about resetting local uncommitted changes first, and look at the difference between a reset and a hard reset or a reset all. So let's say we wanted to try some stuff out in our scene. Like we wanted to move our robot around. Let's say we moved it on top of the box. And we also changed its color so that it was red. And let's say we make the robot even smaller still. Let's say 0.25. So now we got a little red robot on top of the box. Now, go back to source tree. Alright. Let this refresh. We can see that we have a few diffs now. Now the scene has changed because we've moved the robot. The materials changed because we've changed the color. The meta files changed because we changed the import settings. And this meta file is here still because the folder is still here. Now this is another thing that's important. When we discarded the changes before, it'll discard everything that is staged, but it's not going to delete files that are not already tracked in the repository. And the reason that this meta file stuck around is because this models folder is still there. So if we wanted to get rid of this, we would have to just delete the models folder. But let's look at some discards first. So what we could do is we could go ahead and choose discard, and we could select this to discard everything. If we just wanted to choose a couple files to reset, but not everything necessarily, we could just choose them from here. Like let's say we wanted to discard the import settings that change the scale, but we still wanted to leave the material color and the fact that we moved it. That's fine, we can just discard that one file. Let this update. That goes away. Go back to Unity. Now our robot's big again. Or we can go ahead and select this box or just choose reset all. Now, selecting the box to choose everything is similar to reset all, except reset all is a hard reset in the sense that it also resets merge status metadata, which is something we'll get to when we're talking about merges and conflicts, but that's much later on. Go ahead and choose reset all. And let source tree refresh. Now you see we just have, we gotta reload because the file changed on disk. So now we see that we just have that models folder again. And I just want to do a little test here actually. Let's see what would happen if I moved this here. Alright, I'll save the scene. So now I moved the FBX to models again, and of course it's gone in Unity. I'll come back to source tree. Just want to do a test with this untracked file. I want to confirm that it's not getting deleted because it's not tracked, and it's not just that Unity keeps creating it. So let's go ahead and select all of these. So now it has everything as being staged. It's going to add this file here. So now if we choose reset all, okay, that's all gone. Okay, so this is interesting. So if we look in the file system, we see that the models folder is actually gone. But, I'm sorry, yeah, we see that the models folder is actually gone. If we come back to Unity, oh, it's gone again. Okay. Well, I'm not sure why it didn't go away the first time then. That might have been because I chose the files rather than doing a reset all. Let's get to the bottom of it. Drag this in there. Freaks out Unity. Come back here. Let this refresh. Select everything. Discard. Check everything like we did before, or the first time. Discard these changes. Okay. Oh, very interesting. So again, that's another difference between a reset and a hard reset. So if we had just chosen reset, and it's not going to let me discard this file because it's not tracked. So if we just choose a reset, it will undo the stagings that we have, but it's not going to remove a file that's not tracked in the repository. Whereas if we do a reset all, it will also remove a file that doesn't exist in the repo. And since we still have this meta file, the models folder is there as well because it wasn't deleted because we didn't do a hard reset. Alright, very interesting. So that's our original robot, and we have this empty folder that was not deleted because we didn't do a reset all. Good stuff. Any diffs here? That ought to go away in a sec. Alright. Rad. Now let's talk about reverse commits. So a reverse commit is another way to get rid of something that you've done, but it's different from uncommitted changes because it's going to change something that's actually in the history of your project. So let's go ahead and take a look at that, and we'll do this example by adding an image to our project. Let's go ahead and add this IGDA logo. You can probably just drag it right on it. That's neat. That's a bit much. How about you stay flat, you face forward. Alright, cool. Let's check it out in source tree. And sometimes when source tree can be taking a while, I'll just switch one of the filters, and it seems like that can force the view to update sometimes. So just a little tip for you if you run into that as well. So we updated our scene. We added this new image. We got a material for it. That's all good. We want all that stuff. Let's go ahead and commit it. Alright. Added logo to box. I'll say logo image to box. Great. Now if we decided, you know what, I'm actually not really happy with that commit. I want to go back to how things were before. We can check out our history. Select this last commit, because we have more stuff in our history now. Right click on it, and then choose reverse commit. It'll ask us if we're sure. Let's say yes. Then what it'll do is it will produce a new commit in our history with the exact opposite effect of the previous commit. So the previous commit added these files and changed the scene. This new commit deletes these files and reverts the scene back to how it was before we did that commit. So we go here, we reload disk, and now the images aren't there. The scene is back to how it was. If we decide, you know what, actually likes that image, let's reverse our revert. We can certainly do that as well. And it'll revert the revert. Oh, and it'll automatically, make a commit message that just says revert. By doing that, it will undo the negative of deleting these by adding the images back and changing the scene as well. Okay, now there is yet another way we can reset changes, and that we can reset files to specific commits, also known as checkout version, and this is really, really powerful. So let's demonstrate that in our scene as well, but this time we'll use a script. Call this script color changer. Open it up. I know Visual Studio can take a little while to open up, so I'll start working on the script just in Notepad. Alright. Now, actually, before I even start working on the script, let's go ahead and commit it. I think this will help show what's happening in the history. Our Visual Studio is ready. Great. File list. Alright, well, here is our script. Let's go ahead and stage these and add them. Added color changer script. Great. Now let's make it do something. We're just going to make the box change color when we hit the spacebar. So first, let's make it change to the color red, but not all the way red so it doesn't overpower the logo in there. So that'll refresh. Just want to take a look at our history. Let that load itself up. Alright. Added the script. Alright, great. Let's go ahead and take a look at this. Alright, change the box to red. Let's change something else in our scene as well. Let's add another cube to it. Just put that there. Okay. Save the scene. And, make sure that both of these turn red. Perfect. Let's go ahead and commit that. Alright, so that's the diff to our script, and our scene has changed as well. Stage both of these. Alright, so updated color, change script to become red, added box to scene. Let's make another change to our script. This time it can change to green, and we'll add a third box. It can be here. Alright, cool. Let's go ahead and add this stuff to our repo as well. Alright, let's change to our script and the change to our scene. Added third box to scene. Made color changer go to green. And let's change it one more time. This time, let's go to blue. And we'll even add a fourth box. Oh, whoops, what's mine about? Float to double. No. I don't want all the way blue. No, just kind of blue. Alright. Cool. Now, let's commit this as well. Come on here. Alrighty. Alrighty. So, start change. Our scene changed as well. Commit all that stuff. Added fourth box, color changer goes to blue. Alrighty. Now, let's say I wanted to change the color changer script so that instead of going to blue, it goes to red like it used to. Now, well, one thing I could do is I could go to the history And I could do a reverse commit here, which, oh wait, history needs to update as well. Alright, so I could do a reverse commit here, which would remove the third box and have it go to blue, which would make it this commit. Then I could try doing a reverse commit of this as well, which would remove the third box and make it go to, and change it from going to green so it would go back to red. But that seems pretty messy. A better solution would just be to go to the script as it was at that point in the history, then to right click on it and choose reset to commit. So now it's asking me, are you sure you want to reset this file, color changer, to the state at this commit? And you know, every commit has a unique ID. This one is CCDD, you know, whatever. And that is exactly what I want to do. So now I've reset it to that commit. I look in the working copy. It actually doesn't create a new commit when you do a reset to commit or a checkout to version. It just changes the file. So we see that it's edited. And here, RGB, this is going to be red. So now if I check it out in the scene, oh, still refreshing. If I check it out in the scene, this is great. The script is that earlier version, but the scene is still updated. So I still have the 4 boxes here, but now I can try it out with the script from that version. And if I decide, you know what, maybe not green, maybe not red, let's try green instead. So I can go to that commit. Let this go ahead and update. And I can go to that script again. Reset to commit as it was in this state. Okay. Files updated. Come back to Unity. Let it refresh. And launch the scene. And now I've got 4 green boxes. So that's pretty cool as well. I can definitely always go back to an earlier version in my history and recover that file. And if I decide, you know what, that old stuff was fine, but I'm happy with the way it is now. You know, blue's a fine color. I can discard those changes, those local uncommitted ones. Run the scene. I got 4 blue boxes again. And, you know, I haven't even changed my history. So I really, really want to hammer in the point of how useful this is. You know, if you are committing often and you have good commit messages, no one ever has to lose any work, because you can do reverse commits and you can reset your files to specific commits. So this can be a really, really invaluable tool, frankly. And regarding commit messages, you don't want them to be too long, you know, because you know, you don't want to have to read too much when you're going back later. But you do want them to be descriptive. So do your best to explain exactly what's happening in your commit, you know, with the fewest amount of words. And it's also good to commit often so that you have a lot of points of reference. Because if I was just trying things out, like changing the color to red and then to green and then to blue, but I didn't make commits for each of those versions, then, you know, I wouldn't really have a way to refer back to it. So that's another benefit of committing often. This is sort of a contrived example because it doesn't seem like there's any reason I'd want to change to any of these colors. But let's say you're working on a game and you're adding a really big feature that has a lot of small parts to it. You know, first you need to add, you know, one function, then you need to add, you know, another kind of file, then you need to, you know, hook them together. It's definitely good to have commits at each point in that process that you feel makes sense, so that if anything goes wrong, you can always refer back to it, and that your differences between commits aren't too big, especially if you're doing something like hunting down a bug. It's good to have lots of points of reference that you can go back to. Now let's talk about asset serialization. So asset serialization is an option. Go back. Asset serialization is an option you get in Unity for how you want it to save your files. Now by default, Unity will save files as a mixture of text files and binary files, but we can force it to do either. For our purposes with version control, I highly recommend forcing your files to text, and this is how you do it. You go up to Edit, choose Project Settings, Editor, and then Asset Serialization Mode, choose Force Text. It's going to update everything in the project, and save. We come back to source tree and look at our working copy or file status. We've got all of our project settings in here. We got our scene, we got our materials. So all of these are about to be changed to text. There's no diffs on them now because they used to be binary, but afterwards, if we commit this and we change them, we will see some diffs. Set assets serialization to first text. Alright, now let's try changing something in our scene. Let's grab one of these boxes and rotate it a bit. I'll save that. Now let's take a look at it in source tree. So we see our scene has changed here. And what is all this stuff? So this is something I want to mention that the thing about forcing text with scenes and prefabs is that it saves them in a format called, I believe it's called YAML. And even though it's technically human readable, it quickly becomes unwieldy. Now the main benefit of having your files forced as text is not only that you can do diffs on them, but these files will be able to be merged, which is something we're going to get to later when we talk about merging. But every time you change something to your scene, the diffs that are reflected might seem a lot more complicated than the little change you made. Now in my opinion, I think that all of this happened because this is the first time we've changed our scene since it was changed to text serialization from binary. So it might be rearranging some stuff as well. So let's go ahead and just commit this anyway. And I'll change it again and show you what that looks like. Rotated box. And we'll rotate it a little more. Now, let's see if the diffs are going to be any friendlier. There we go. So these diffs are a little easier to read. So again, oh, it's showing, the local rotation, but it doesn't really have the name of the file that's easy to discern. It has the file ID, but we can see the differences in there now. So that is what happens when you have forced text for your asset serialization. It's really great because it's going to let us merge things eventually. It's also going to let us see diffs, and sometimes the diffs can be helpful, but I wouldn't necessarily count on it. Also, I've run into situations, and I've heard from many other people that have been working with Git and Unity, that sometimes it seems as though they're working on a prefab, and they commit it, and they come back to Unity, and it seems as though the changes to their prefab have been lost. I've seen this myself, and I believe that the problem is that, or the problem happens when you're working on a script or a prefab and you play it in the scene, but you don't necessarily save the scene or save the changes that you've made before you come back to Git. Unity might keep those changes in memory and not commit them to disk until you explicitly save the scene. So my recommendation is to make sure you always save a scene before you commit anything in source tree or any other way using Git. Personally, I always go back to Unity and save a couple times. I just, kind of mash Control S. And when I do that, I don't really seem to run into that problem. So again, I would recommend that to you. Make sure you definitely save a scene before you commit it. Okay, rotated box again. So let's talk about stashing. Stashing is a local backup that isn't added to the history and can be applied at any time. Stashing is useful for when you're in the middle of something that you don't want to throw away, but you need to update your working copy. Stashing allows you to save your work. Let's do an example. Let's say I just wanted to do something trivial like move this box. Let's go to source tree. Let's see the diffs to our scene. This pops up. Alright. And instead of committing this, what we're going to do instead is choose stash. Move box up. Just hit OK. So now it's stashed that change in this stashes area here. It's the branch it's on, it's the name for it. And it reset our working copy to how it was the last time it was committed. If we want to check this change out, we can just go ahead and apply the stash. Come back, and then that's our change again. So again, stashing is something that's really useful for when you are working with other people and you need to sync your project from the central repo and you don't necessarily want to commit the stuff you're working on. You know, you can stash it and then update your working copy and then apply your stash. Also, if there's a file or some changes you've made that you just want to reapply later, you can use a stash that way. So it's a really useful and interesting tool. Go ahead and get rid of that. And it's really just another way that Git allows you to experiment with your project and make you freer to try different things out. Okay. Alright, now let's remove some stuff from our repository. Or at least, let me show you how to do it. So there's two ways you can do it. You can remove a file, which will also delete it on disk. You can also just stop tracking a file, which will remove it from your repo, but keep it on disk. And that would work like this. Oops. Let's say that first I want to look at the clean files. And let's say that I wanted to remove the robot model and the meta file. So I could select these two, and then I could choose remove. See, and what that did is it just deleted the files altogether. If I looked at pending changes, let this update, has these two files getting deleted. That's what the minus sign is for, or removed rather. Let's go ahead and discard these. Yep. Now they're back. A different option would be to stop tracking the files. Alright. And that is also known as a cached remove. So what that will do is it will remove it from our Git repository, but it'll keep the files in the file system. And this is a good thing to do if you realize you have a file in your system or in your repository that you'd like to ignore. You want to keep it around, but you want to ignore it. Then you can just stop tracking it. We could add these paths to the ignore file and then commit this. So any future changes done to the robot FBX or its meta file will not be captured by Git if we add them to the ignore file. And that's done by deleting the files, and that's done by choosing stop tracking rather than just remove. And it's also the reason it shows them down here as unstaged, because it still sees that these files are in the system. So it's like telling them, hey, we don't want to track these two files anymore. It's like, okay, sure, but I see two files called that. The way we would get rid of these is by adding these paths to the ignore file. But we don't want to do that either, so let's go ahead and reset all of that. Now everything should be back to normal. That refresh. You can see these right here.
And let's take a look in Unity. Everything looks good. Okay. Alright, new scenario. Now let's say we're working with a server. Why would we want to do this? Well, for one, we can back up our stuff to the cloud, which makes it much more reliable, much more safe. If we have a backup saved on a host somewhere, then we're good in case anything happens to our computer. Our code is backed up, our project is backed up, and we can feel a lot more secure about the state of our project. Also, this way we can sync multiple machines. So if you've got work on your home machine and your office machine, or your school machine and your home machine, or just two different machines at any different location, two or more, you can sync up this way via your external server. And you can also publish your work this way. So big benefit of having services like GitHub and Bitbucket is there are a lot of open source projects out there that people use to just collaborate, and you can host them on something like that with version control. So okay, we're going to add a remote repo, and the first thing we want to do is to choose a hosting service. Now, I've mentioned GitHub and Bitbucket a few times. There's also a few others that have free options. There's GitLab, for example, and there's several other ones that have paid options as well. So really just pick whatever is going to make sense for your project and your team, whatever you guys are doing. We're going to use Bitbucket. The reason we're going to use Bitbucket is that it has free private repositories. It has free teams of up to 5 people. Now there is a 2 GB repository size limit, but we should be good with that. And also it integrates pretty well with SourceTree. Now there are 2 ways to create a new repository with Bitbucket. We can do it on the Bitbucket website, or we can do it through SourceTree. The main difference is that if we do it in SourceTree, we're going to get the HTTPS URL for our remote repository right away, where we won't see that if we make the repository in Bitbucket on the website. I'll show you what I mean when we get to HTTPS, but for now I'm just going to make the repo on the website. So let's go ahead and go to Bitbucket. Alright, now let's log in. Looks like it remembers me. So this is Bitbucket. These are some repositories I'm associated with. And these are some of my repositories. All of them are private. And let's go ahead and make a new one. Choose Create Repository. We'll call this one VC Talk. It's going to be private. It's going to be Git. We can give it a description. We can add issue tracking and a wiki. This is stuff you can add later. We don't want to import a repository in this case, because what import will do is that it will import it from another hosted location. And ours is just local to our machine right now, so what we want to do is create a new one. Alright, so this is our repository. This is the location for it. Now, unfortunately, the options that Bitbucket gives us here aren't really great for importing an existing local project. So what we could do is we could choose clone and SourceTree, but that's not really what we want to do, because this is an empty repository and we already have a project here with with a few things in its history. So we don't really want to start with this empty project. Also, we're not starting from scratch. We could do this option here, saying we have an existing project, but what I wanted to do is really spare you guys the command line. So if we cloned this project, we'd be starting with something empty, and that's not what we want to do. And I want to keep this out of the command line to the extent that I can and just use SourceTree. So let's see what we can do instead. Now, what we really need to do is just add the remote URL to our local repo. So we can just go ahead and grab that And the thing that's weird about this is that when you create a brand new repository in SourceTree, it doesn't show you what your remote URL is, and it's not the same as your website URL. The remote URL is actually, well, it's actually going to look like this. There's two different kinds. There's an SSH remote URL and an HTTPS URL. And the difference is how they authenticate. And they have these types of patterns. So actually down in the command line arguments, it's going to have a remote SSH URL that we can use. So we're just going to copy it from there rather than doing all these instructions. Next, we're going to go back to SourceTree, the repository, and then repository settings. For remotes, we're going to add. This can be the default remote. Will just be called origin. And then for the URL path, we can just paste in the path that we got from the Bitbucket website. The host will be Bitbucket. It's got my username here because I've used it before, but if it didn't, you can just enter it for your Bitbucket host. And automatically has Bitbucket, GitHub, or unknown. If you want to use another host, you can just enter the information for that. So let's just say OK. Alright, so now we have remote connected, but we're not quite ready to go yet. Alright. Get to my notes. Alright, so before I go further with that, I just want to explain that there are two main types of remote Git URLs. Like I mentioned before, SSH and HTTPS. There's actually a third one, but the third one is kind of like Boo, the Forgotten Unity language, and that's Git. That's the Git URL, and it's a special protocol. Now, the differences between these is how they authenticate, like I said before. With SSH, you use SSH keys, a private and a public key pair. The private one's on your local machine, the public one is on the server where your stuff is hosted. And with HTTPS, you just use a username and password. With SSH, it's a lot more convenient from the command line if you're using SSH keys because since the private key is saved on your machine, you don't have to be prompted to enter your password all the time. So I'm going to be showing how to set up both types of authentications, and we're just going to go ahead and do SSH first. Oh, and again, this is what a SSH URL looks like. It has this kind of path with the user name, repo name. It's going to end with .git for a Git repo. And this right here is going to be the address of your user and host with SSH. So let's go over the basic flow with an SSH remote. And what we want to do is create an SSH key pair, public and private key. Then we just add our public key to the remote repo. And we can do this in our Bitbucket account settings. So this is really straightforward, on a high level. It's just that there can be a number of steps to get there. So first, I'm going to show how to do this on Windows with PuTTY, because this is going to keep us out of the command line. So as I demonstrated before, we added our remote already in our repository settings, but it doesn't mean we're going to be able to push our stuff up to the repo. We can go ahead and try it. Let's say we want to push our master branch. But if we look at our output, it's just going to get stuck here. And the problem is that the server's host key isn't cached in the registry. So we look here, it says you have no guarantee the server is the computer you think it is. It is because we trust Bitbucket. It has this fingerprint, and if we trust it, we need to enter Y. The problem is we can't enter anything in this prompt. This is actually, in my opinion, sort of bad design in SourceTree, and they ought to update this. So I'm going to go ahead and cancel that. Oh, by the way, if you want to follow along with what I'm doing, make sure that your SSH client is set to PuTTY plink and not OpenSSH. We're gonna do that next. So we're working with PuTTY, and the reason that we couldn't push is because we hadn't accepted the RSA fingerprint of the server. And in order to do that, we actually need to SSH into the server, or at least attempt to. So let's do that by running PuTTY. You can go ahead and download PuTTY from there. And once you have, you just run it. I got a few servers that I've accessed before. But basically we can just write bitbucket.org. Can leave everything else the way it is, and click open. And now this is actually that same prompt that we were getting before in source tree, but now we actually have an option. And here we're going to choose yes because we trust Bitbucket. Whoops. Let's go back here, log in. We're not actually going to be able to log into the servers, but we can try. And it says, not supported authentication no supported authentication methods, but that's fine. We accepted the RSA fingerprint, and that's all we really wanted to do. So if we go back to source tree and try to push, let's see if we get any further this time. Alright, so this is a little better. It's different anyway. Fatal error, disconnected, no support authentication methods, server sent public key. So that's right, we don't have any keys yet. Now we trust the server, but we don't have, we're not authorized to communicate with it. So what's it telling us here? Launch SSH agent. Okay. Authentication via keys failed. You want to launch the agent. If you don't have a key yet, you can create one or import it using the menu options. So I think we're going to do that. Let's go ahead and hit no here. It's running, but the server rejected your connection. We still need to load the correct keys. Sure. Let's go ahead and do that. So with PuTTY, there's something called the PuTTY key generator, and that actually does come with source tree. You don't need to download that. You just need to download PuTTY exe so you can do that one connection that we did with Bitbucket. So now let's go ahead and generate a key by clicking generate. It's going to ask us to move the mouse around to generate some randomness. I always think this is pretty cool. Alright, so now we have generated our keys. Let's go ahead and save our private key. You can choose a passphrase if you want. I personally don't choose passphrases on mine because I feel as though it's pretty secure just having a private file on my computer. But if you want that extra layer of security, you can also enter a passphrase here. Yeah, I'm sure. I'm going to save that just in a folder called PuTTY keys. And I'm going to call this BB for Bitbucket, and the extension will be .ppk. Alright, now I also want to save the public key, but something to be mindful of for Bitbucket is that it doesn't recognize PuTTY public keys. It's going to recognize your OpenSSH public key, which is what's in this area here, OpenSSH, but not the PuTTY key. So it's important that you definitely copy this. Right? I'm going to go ahead and save this anyway. I'll give it the same name as this, but call it .pub.text. So it'll be easy to see. And we can take a look at it. Do you want to reload it? Yeah, sure. Oh, right. We changed this a few times. That can go away. So this is what our PuTTY public key looks like, and I'm just going to paste the SSH key here. So you can see it's similar, but it's not quite different. Now that we have this private key, let's go to our options. Oh, I'm not sure if this was here before, but if it wasn't, make sure that for your SSH key, you just choose the Bitbucket key that we generated, the .ppk. Alright. And then let's go back to Bitbucket, and then go to our settings, and we'll go down to SSH keys. Actually, I have a few keys that I've used for other things, and now we want to add a key. We'll call this one Windows source tree. And just to demonstrate to you guys that, the PuTTY keys will not be recognized, I'll paste it in here. Add key invalid. Oh, maybe it doesn't like these comments. invalid. Maybe it doesn't like the new line. Invalid. Maybe it doesn't like that comment. Oops. Get rid of that. Invalid. Yeah, so like I was saying, it's not going to recognize your PuTTY key, but it will recognize your SSH key. No problem. Rad. So now we have a Windows source tree key. You should get an email for that via your whatever email address you have associated with Bitbucket. Now let's go back to source tree and let's try to push. And pushing is what will take your local changes and push them up to the remote repository. We're going to cover that in more detail after we do all the setup. Alright, so okay. Check out the output. Do you want to launch that? Oh, yeah, sure. Please click. Sure. Oh, say no. Let's see. So now, let's view our keys. Oh, whoops, we hadn't added our key. Let's go ahead and add it here. PPK. Alright, so now we have a key in our pageant list. And let's go ahead and push that again. The output. Alright, completed successfully. So it's all green, looking good. Now we're showing remote branches, and this will refresh. I will come back to source tree. And we got our repo here. It's just updated. VC talk. Load this up. Alright, now it looks pretty different. So we see we have 14 commits here. Now it's showing us our repository URL where it wasn't showing that before. We can select HTTPS before. See, it didn't really give us this option. And now we can inspect our project. We can look at our commits. There's all the stuff that we've done. We can click on them to see the diffs for them. So this is really great. It gives us a lot of information here. We can just browse the files here. You know, we can check out different branches. There's only one for now, but we'll go over those later. And let's take a look at an overview of our project. And that is how you connect a remote repo using PuTTY. You want to generate the private key. You want to make sure you copy the public key text because the public key you get from PuTTY isn't going to be recognized by Bitbucket. You go ahead and you put that up in your Bitbucket settings. And then you're going to have to SSH into Bitbucket to accept that RSA fingerprint. Okay, so that is how you connect a remote repo on Windows with PuTTY. Now let's do it cross-platform with OpenSSH, and we're going to have to go to the command line here because you don't have PuTTY on OS X, and I want this to, I want to explain how this is going to work cross-platform. So, first thing I'm going to do actually is remove my settings. I've already set this up before, but I'm going to get rid of my old key just to show you guys how to do this. So that was my old Windows SSH key. Alright, so now OS X, Ubuntu, they're still there. Alright, cool. Alrighty. Well, let's go to source tree. And in Windows, what you would want to do is, in your options, change this from PuTTY to OpenSSH. Now, you're not going to have an option to do this. You're not going to have to do this in OS X because I believe that only uses OpenSSH. Let's go ahead and hit OK. So now, let's see if we can talk to our server. Let's try to do a poll and see what it tells us. Okay. Well, it says it's running, but it rejected our connection. You may need to add a key. So again, we need to add a key. Please note that the manually logging in with username and password is not supported via OpenSSH. Right, that's for HTTPS. We're going to get to that next. So we need to add a key again, but the keys are different for PuTTY and for OpenSSH. So the key we added before was a PuTTY key that was generated, and we had the OpenSSH public key for it that we added to our Bitbucket settings, and that was to use PuTTY with source tree. But if we can't use PuTTY because we're on a Mac, for example, we're going to need to generate our SSH keys the old-fashioned way. So the way we'll do that is by clicking on Terminal, and that will launch a command line terminal in the location of our project. That's what this is. All right. And we're going to have to enter some commands. So master is actually the name of the branch we're on right now. So the first thing we're going to do is to go to our home directory, and we're going to do that by just typing cd. And that should just take you to your home directory. Now what this is, oh, by the way, what this is this is the Git command line client on Windows, and it's not quite DOS. It's actually like a million times better than DOS. For one, you can resize it easily, where in DOS you have to go to the options, and it's really annoying. Also, the way that this works, it takes commands for bash, which are different from DOS, and it has kind of a Unix layout, and if it sounds like I'm just speaking some kind of gobbledygook language, don't worry about it too much. I'll try to make this straightforward. So anyway, type cd. That'll take you to your home directory. If you want to see where that is, you can type pwd for print working directory. And it's typically going to be something like this, the drive, users, and then the name of your folder. So then what you want to do is type makedir.ssh, right? And that's just to see if the folder exists or not. So I already have an SSH folder. Let me see. Do I want to have an SSH folder already? Let's go here. What's in here? Known hosts. I'm going to start fresh, actually. I'll get rid of that. Whoops. Okay. So, make dir.ssh, which will make a SSH folder. You can. The reason I have you always typing that is because it won't create a new one if it already exists. Don't worry if you type makedir.ssh and it says one already exists. You don't have to delete it, especially if you don't know what it does. In this case, I know what I'm doing, and I just wanted to show you guys what it looks like from scratch. So that's why I deleted it. I actually have a backup SSH folder as well, so I'm not really worried about it. But yeah, go ahead and type makedir.ssh, and it'll create a .ssh folder if you didn't have one already. And if you do, it'll just tell you that you have one already, in which case you're probably fine. So now we want to go into our SSH folder by typing cd.ssh, and cd is change directory. So now we can see that we're in our SSH folder. It's got it right there. If we want to look what's in it, we can type ls for a list of files. Right now there isn't really anything in there. So what we want to do now is to create an SSH key with command ssh-keygen. And just hit enter for that. Generating public-private RSA key. Now it's going to ask for the file in which you want to save it. And this is the default location. It's going to be, the .ssh folder where we are, and it wants to call it id_RSA. I like to give my SSH keys more descriptive names, so let's go ahead and call this bb_key. Alright, now it's going to ask for a password, just like it did when we generated our key in PuTTY. I'm going to leave this blank by just pressing enter, and press enter again. Okay, so now that is our SSH key that's been randomly generated. If we go ahead and list our files, we can see that we've got two things in there now. So, what we need to do now is to create a config file, and the reason for that is we need SSH to automatically know about our private key file. Now again, don't get intimidated by this, it's going to be very simple. So there's a couple ways we can do this. We can do it from our file system. In our root folder, we can go to the .ssh folder. Let me refresh. We can go to the .ssh folder we just created that has BB key and the public key in there. And then we can just say, you know, create new text file, and we can call this config. Just config, not txt. Are you sure? We are sure. And then you can go ahead and open this up. I use Notepad++, but you can open it up with, you know, regular Notepad or whatever you need to use to open up a oh, what's going on here? Whatever you need to use to open up a file without any extension. Uh-oh, did I move something? Copying from cancel. Oh shucks, I was moving that. Let me not do that. Do that. That's weird. Anyway, so we got this config file. We got it opened up here in Notepad, and now it's empty. And it's right where we want it. It's in our .ssh folder. And now we want to add the following to it. Shrink this. Alright, host bitbucket.org, and I'll make a tab there. User will be git. Identity file will be tilde, which is right next to 1. Just shift in the key next to 1 on a Windows keyboard / .ssh/bb.key. Now what tilde means is it represents your home directory. So if we go back to the command line and actually you can just see it right here. So it has tilde /.ssh. That's the location where we are. If we type pwd, it would expand to the full term. So that is going to be the location for where we are right now. Tilde is just tilde is just sort of a shorthand, say that 5 times fast, for your local user folder. So it can apply no matter what machine you're on. If you know your username was Kojo or Bob or whatever, tilde / is just going to refer to your local user. Alright, so we have our identity file here. Go ahead and save that. And close this. And now we can test our connection by typing ssh t git at bitbucket.org. Alright, it's asking us again if we want to accept the fingerprint. Let's say yes. Alright. Now in this case it says the permission is denied, no public key. Well, let's try putting our public key up there. First, let's take a look at it. Open up the public key. This time I'm just going to use Notepad++ because it's right there. This looks familiar. Let's copy this. We will go back to Bitbucket, our SSH keys. I'll add a new one. We'll call this one Windows command line SSH key. Just paste that in there. Alright, so that's in there. Now let's try to do that command again. I can just press up to do the last command. Okay. Now it's saying permanently added the RSA key to the list of known hosts, but no such identity, BB key, no such file or directory. Well, I guess it doesn't know about our config. It probably doesn't because we created it after we opened up the terminal. So I just went ahead and closed that. Let's try opening up another terminal, see if we have any more luck. Again, that command we're entering is this one. And we can enter it from anywhere. SSH t git at bitbucket.org. It's still telling us there's no identity there. bb.key. Let's take a look. cd h. Oh, whoops. It's actually a bb_key. So edit this config file. Right, I put it as bb.key, but here it's actually bb_key. So let's correct this right here. Alright, let's save that. Now, let's try SSHing again. It's up, oops, there it is. Alright, it says that we're logged in. Okay, so that is what we had to do. We had to, open up the terminal, cd, get into the SSH folder, do an SSH keygen for the name of our key, which we called bb_key. After that, we had to copy the public key up to Bitbucket, just like we did with the PuTTY keys. We had to copy this stuff, go and choose add a key in Bitbucket. This is our key here. We don't need to change the name, but pasted that in there. And then we added a config file in our .ssh folder. The config file looked like this. Okay. Where the host was, where we're hosting our stuff, bitbucket.org. If we were setting this up on GitHub, for example, the host would be github.com. The user is going to be git, and the identity file is the path to the private key we created, bb_key, not bb.key, bb_key. Then we were able to test that from the command line by running this command, ssh-T git at bitbucket.org, which is our host. Alright, if you have any more questions about this stuff, there are a bunch of resources online for SSH keys and SSH connections. Here's some documentation provided by Atlassian for SourceTree. So they have some more detail that they go into with some of this stuff, and you can see how you could set up on Windows as well as OS X and Linux. Alright. There's even some other stuff you can do here if you need to make sure that this happens automatically. You can update your bashrc file, but I leave you to having all that fun. Alright. Now let's see how a remote repository would work with HTTPS. Now the flow for HTTPS is it's a bit simpler. What we want to do is set our remote URL and then enter a password if prompted. Now this time I'm going to create another repository. Oh, get rid of this. I'm going to create another repository via SourceTree just to show you what that looks like and to demonstrate how it gives us the HTTPS URL right away. So we can choose to browse. Oh, we're not connected to our Bitbucket account. Well, let's go ahead and do that. We can edit accounts. There's a protocol for us. Edit. Need to give it a password. Go ahead and get my Bitbucket password. Oops. Copy password. Alright. Paste that. Log in. Alright, cool. So now, we're going to say the preferred protocol is HTTPS here. Alright, close that. Now this refreshes and it's going to show all these repos that I'm associated with. Now I'm going to go ahead and create a new repo. And make sure you create it on your Bitbucket account. I'm not sure you can actually host repos on an Atlassian account. I'm going to call this one VC Talk HTTPS. And I'm not actually going to use this one. I just want to demonstrate how to show it and what the flow with HTTPS is like. So I'm going to go ahead and create this repository. Alright, there it is right there. Double click it. Or choose OK rather. And now we have this source path for it. And we don't want to clone it because, again, this is an empty repository. There's nothing in it. Alright, see, it's empty. But the benefit is that we have the HTTPS URL for it right away. Whereas we didn't get that before until we created the repo. What it did offer us was an SSH URL. So what I'm going to do instead is I'm going to copy this URL. I'm going to choose cancel. Then I'm going to go to this repo here. I'm going to go to the repository settings. And let's see. I could add another URL, but instead I'm just going to change this one to keep it a little simple. So instead of using the SSH URL, I'm just going to use the HTTPS URL and just choose OK and OK again. And now if I wanted to pull or push something, let's go ahead and try it. I'll just push, show full output, and everything was cool. And the reason it didn't prompt me for my password again is because I had already given it. So if I had removed my password, or it didn't have my password for some reason, like I deleted it, and I tried to pull, show my output, oh, looks like another window popped up here. Needs to authenticate because we're using HTTPS. I guess it's not my password in there anymore. Let's go fetch it. Alright. Copy password. Drop that in there. Log in. And we're authenticated. And we're good to go. So, in some regards, HTTPS is actually a lot simpler than using SSH. You know, it's gonna be much easier to use if you're using source tree, for example, in an app like this. But if we were using the command line, every time you want to connect with the remote server, like doing a push or a pull or a merge or something like that, you're going to have to enter in your password, and that can be really cumbersome. So, you know, pick your poison. If you're going to be using source tree or an app a lot, then I would recommend using HTTPS because there's much less setup. The only thing that's sort of tricky about it is if you create your repository on the Bitbucket website first, it's not going to show you your repository URL. Whereas once you do have your repository set up, you can select it just like this. Now there's a certain format that it has, so you might be able to just deduce it. You know, like the SSH URL is going to be pretty much like this, but it's going to have a -https after it because it's, you know, username at Bitbucket, then user and repo name. But yeah, you know, just kind of decide what you want. If you're going to be using the command line at any point, I recommend using SSH or PuTTY keys. And if you, if you're going to be using the command line at any point, I recommend OpenSSH. If you want to get a taste of what that's like, but you're still scared of the command line and you're on Windows, I recommend using PuTTY. And if you just want simplicity, I recommend using HTTPS. That is simplicity and with no command line. You can use HTTPS with the command line, but you're going to be entering your password a lot. And that's definitely something that bugs me, but you know, maybe it won't for you so much. And this was just set up for demonstration purposes. Actually, did I push to this? Let's see. I did. So now I have two repos here. HTTPS and the other one, VCTalk. Well, I don't need two repos of the exact same thing. I'm going to keep the original one. So we'll come here. Stick with SSH. Change my repository settings. You can have more than one remote, actually. You know, I could have both of these remotes in there, but I don't want to do that just because it's sort of strange to have two remote repositories for the exact same thing. But if I had the code hosted elsewhere, like on GitHub, for example, or on Stash, or on someone's private repo, you know, then I could have access to all of them, and I could choose which ones I wanted to pull from. So let's do that. We'll go back here, and we can get rid of this one, the HTTPS one. Settings, delete repository, and deleting it is fine because we have another repository with the exact same stuff. And it's still backed up on my machine too, so nothing is really lost here. And cool. Back down to these. Alright, and now also in our remotes we can see that we have origin set up here. And origin's the name of the default remote, and then it has a branch for it as well. So here it's showing each of the branches. Right now we're in sync. Our local master branch is in sync with the origin master branch. And remote branches are always going to have a name like this, where it's the name of the remote, a slash, and then the name of the branch. You can toggle whether or not you want to see remotes with this checkbox. And that is working with the server. Let's go over another scenario now. Let's see about working with multiple machines. And we can still imagine that we're working solo here. So the first thing we want to do is to clone a new project. Alright. So we can go ahead and clone the project. We'll give it a different name than the repo that we have here. It's also going to be in a different location. Let's see. There's a couple ways that we can clone a project. We can do it either from source tree directly by choosing clone new and giving it the remote repository URL, or we can do it from the Bitbucket website by choosing this right here, which will clone it in source tree. So this link needs to be open with an application. It's a source tree link. So we'll do that. Now source tree is getting our attention, and it recognizes that we have this repository already. So we can just say, we can just open that repository if it thinks that's what we want to do, or we can clone a new one and just put it elsewhere. And let's do it the other way, just to show you guys what that's like. And this time I'm going to clone it with a HTTPS URL. I'm going to use it this way because I suppose it's more general. If you're using GitHub, for example, I don't think that there's a button in there to clone from source tree. So we're going to choose the repository URL. It is checking the type. It figures it's a Git repo. I'm going to choose a destination path for it. And we're going to put this one right next to the other one. So we're going to call this one VCTalk other. Alright. No, path does not exist. Oh, well, let's make it. Alright. That's where it's going to be.
and this is going to be the name. Now we're going to clone it. Alright, now like I said before, in our bookmarks we can see more than one repo. We have multiple tabs here because we have multiple repos here. Now both of these actually point to the same repository. You know, they have the same histories. So there isn't going to be any difference there really. Now this also has head, and what head refers to is it's a reference to the current version of the project that's checked out. So I guess this has that there because we just cloned that project, whereas we didn't clone this project before. Alright, now there are 3 main actions that you take with a remote repo. Those actions are fetch, pull, and push. We already did push before to get our local repo up onto the remote, but I'm going to go through these 3 again anyway. So fetch isn't really something you use much when you're working solo. What it does is it gets the information for the latest changes to your remote repo, but it doesn't integrate them into your working copy. So let me show an example of that. We'll do that by creating a README file. So this is going to be a default README file. I don't need to put anything here. I don't know. This is our version control README file. And we can go ahead and save that. And now we have a README file. And this is actually added to our repository as well. This was a commit. Oh, this is something I didn't mention, by the way. It's a nice feature of SourceTree. We can actually edit files on the website as well. So, you know, if we wanted to commit a file called foo.txt, for example, we could do that, commit it, and leave a message and everything. So that is a pretty nice feature. What we just did there is, what we just did earlier is we added this README file, edited that online. Now if we go back to SourceTree, and first we'll look at our main repo, and okay, so we have this pull notification. Let's see. I don't think I even had to fetch that time, but go ahead and fetch. Let's get the latest changes. And we can see that origin master is ahead of master. Again, I want to remind you guys that remote branches are referred to by the name of the remote repo and the branch name. So origin in this case refers to Bitbucket. Its name doesn't have to be origin. Its name could be whatever we want it to be. The name could be Bitbucket. It just refers to the server that's hosting our repository. And again, there could be multiple remotes here. So we could have a origin remote, we could have another remote for GitHub, we could have another remote for our own private server, you know, whatever. You can have multiple remotes, and each of them can have their own branches. So, you know, things can get very intricate. You know, it has that potential. And again, origin master refers to the master branch that is up on the remote repository. And right now it is ahead of our local branch, which is just referred to as master. So that's where we are, and that's what's ahead of us. And this pull notification is letting us know that we can pull in a change that's happened upstream from us in the same branch, the same master branch, because these branches are tracking each other. If we look at that in the other repo, same thing. So it's telling us that we have this change upstream. So let's go ahead and integrate these changes. We can do that with a pull. Now what a pull does is the same thing as a fetch, except it also does a merge. So it pulls in the latest changes from upstream, but it also merges them into our code. Do that real quick. Pull from origin, remote branch, master, all this stuff is fine the way it is. Alright. So now master is the same as origin master in VC Talk, and in our local project we see that the README file is there. Now let's go ahead and sync our other repo, VC Talk other. And now this has the README as well. I'm going to make another small change because it seemed to me like the pull request came automatically without me having to click fetch. So I'm just going to make a small change and then make sure that that goes up so that we have to fetch it. And how do I want to do this? Let's see. Change the color changer. I think it'll be easier to change a script. Yeah, let's do that. I'm going to open it in text edit actually. Okay. This is a comment. So that shouldn't change any kind of functionality. This is the diff we have here. And this is in our original repo, VC Talk. And now, just for convenience, we're going to check this to push the changes immediately to origin master. Let's see. Added comment to script. So we committed that. That got pushed up. Now if we look at VC Talk other, nothing yet, which is good. Let's look at the commits on Bitbucket. That reloads, added comment to script. That's the thing we just did. You can click there to see the diff. That's what we did. Now, if we go ahead and fetch, actually, don't even do that yet. So on master, we can see that this is the latest that this project is aware of. Go ahead and fetch. Should output if we want. Alright, now we've got some new information. Origin master and origin head are ahead of our current version, so we can go ahead and pull these in. Are you still complaining? Running, but the service rejected your connection. You may need to add the correct key to your agent by selecting this. Oh, we're using HTTPS here. I do recall. Yes, I'll go ahead and choose PuTTY. Yeah, because that can work with passwords as well as SSH. Alrighty. Great. And the last is push, which we've done several times now. And what pushing does is it takes your local changes and it pushes them up to the remote repository. Now, we've finally gotten to the collaboration. I wanted to save this for last to really point out a few things. Mainly, that it's important to know how to use version control yourself. Using it with others isn't actually very different in terms of the actions you're taking. The challenge becomes communicating and making sure everyone knows what's supposed to be going on. I encourage you all to use version control in your independent projects and to become very familiar with it, or at least more familiar with it. After the learning curve, it'll make your work much easier because it'll be backed up more reliably and it'll allow you to experiment much easier. So the main thing you want to do when you're working with other people is just to add them to your repo. And here's how you do that in Bitbucket. Go to your overview, and you just invite users by sending invitations by their Bitbucket username or by their email address. Oh, cancel. You can also create a team if you'd like. It's a team I'm a part of. Give it a name, give it a unique ID, and add members to it. And a team can have its own repositories as well. Okay. Now, this is the key flow for collaborating with team members when you're using Git and when you're using version control. You want to commit, then you want to fetch, pull, merge, and push. You always want to commit first to make sure that your repository is clean and you don't have any uncommitted changes before you try to sync, because if you try to do that, SourceTree might not even let you. But if it does, then the upstream stuff might merge in with stuff that you're working and you could really lose the work that you've done. And a big point to using version control is not to lose any of your work. So commit or stash, whichever feels more comfortable to you. Fetch to see what's about to come down. Pull, merge the code if you have to, then push your stuff. You're good to go. And always, always, always communicate. Remember, all of this is just a tool, and it's supposed to help facilitate better collaboration. But you need to, talk with the people you're working with in the first place so everybody knows what's going on. Another thing to point out is that Git does not have file locking, as opposed to some other version control systems like SVN or Perforce, which makes communication even much more important. Now, it's nice that scenes and prefabs can be merged because we force their asset serialization to text, but since they don't have file locking, it means that you're going to have to communicate with your team members to know who's working on what file when. Now again, scenes and prefabs can be merged, but I don't recommend having more than one person working in either of those files at the same time. So it's probably better to communicate with the people on your team and say, hey, I'm going to be working in this scene right now, I'll let you know when I'm done, rather than not communicating, two people changing something similar in a scene, and then having to merge one of those scene files, and that could get hairy pretty quickly. Alright, let's talk about merging. So I've mentioned it a few times. Now what merging is integrating changes from another branch into your working copy. And again, it's the three core changes we're talking about: adds, edits, deletes, but also renames and moves. Now if a change cannot automatically be integrated, it'll produce a merge conflict. And to deal with those, we definitely want to have a merge tool. But first, let's just demonstrate some basic merging. Do that back in Unity. And let's add a few scripts, because it's easy to work with text. We'll call this script, gonna add, I'll make another one, call this one, gonna edit, make one more, call this one, gonna delete. Alright, so now we got these three new scripts. Let's look at our file status. They're in our main repo, because that's the one that's open in our Unity project. We got three scripts, each with their meta files. Go ahead and add these. I'm not going to push automatically just to show you guys all the steps. Added three scripts. Committed that. And now we have this push notification because our local master branch is ahead of origin master. So we can go ahead and push that up. Go to the file output if we'd like. It's completed successfully. That's another nice thing about SourceTree. It's actually showing us the git commands it's running. Even though I would have just said git push, but whatever. So, okay, so this will produce a simple merge. And the nature of this merge is that it's just going to add those files. So, oh wait, that's our original one. So VC Talk Other. So these are our two repos we've got here. We've got VC Talk, we've got VC Talk Other. Now we can see this one doesn't have a library and temp yet because we haven't loaded it in Unity. But if we did, those folders would be created right away. Maybe I should go ahead and do that. Nah, just trust me. This is how it should look. So I'll go to Assets, and these are all the scripts we just made. These do not yet have those scripts. So let's go ahead and look at our history. We will fetch whatever's upstream, even though we should know. It's those scripts we just pushed. Now we can pull them in. Alright, and now we got these scripts. Just came into our file system. Alright, rad. So that's a really basic merge there. Another merge that could happen is we could just delete some files. So let's go ahead and delete this one. We can delete it on the file system and it would recognize it right in source tree. Or we could remove them like we chose to in source tree. I'm just going to delete them here and go ahead and delete the meta file too, because I know they're associated with each other. I'll come back here, and this is in our other repo. I'll look at the working copy. Alright, these are the files we deleted, -sign for delete. Stage these because we're serious. Deleted a script. So did that, then push that up. The bookmarks also indicate, when something can get pushed and pulled. Come back to our original repo. We're gonna, instead of fetching this time, we're just gonna pull, because we know what's going on. But if you're working with a lot of people and you haven't communicated in a while, it's definitely best to fetch first, just because you might not know what's happening upstream. So now we pulled. Looks like we got that, and if we look here, that gonna delete script is also gone. So let's do something else. Let's try doing edits to a file. So here, we actually have two copies of the same script. So here we have it in our original repo, VC Talk, and this is a copy from our cloned repo, VC Talk Other. So let's add a comment here. Comment in start. Add one here as well. Comment in update. Now we'll commit both of these and sync and see what happens. Well, they're going to get merged, but let's just have a look at it. Alright. Added comment to start function. Good there. Push. Comment other. And let this come in. Alright. Added comment to update function. And now we're going to push this. Now, I don't think it's going to let us push here because we haven't pulled yet. See, I'm not 100%, but I'm pretty sure source tree won't let us push something if we haven't pulled yet, especially if the push and pull affect the same file. But let's go ahead and try it. We're going to get an error. Right. So it failed to push some refs. Those are references, meaning our commits. Hence, updates are rejected because it contains work that we don't have yet. So let's try pulling it in.
So let's go ahead and fetch first, just to be very descriptive. So we can see we have one commit ahead of us, and here we can see that the histories have split. So this is where we are, always where the white circle is. And it says that we're one commit ahead and one commit behind of the remote branch that we're tracking. And the reason that these have differed is because we've both edited the same file here, where before, all of the changes that we've done haven't really, I won't say conflict, but they haven't really intermingled with each other. So all of these merges that we've done have been what are called fast forwards, but here Git's going to have to do a little more work to merge these files. But this should be fine because the changes that we've made are on different lines. But that's why it's showing it branched off like this. So let's go ahead and pull this change in. Alright, looks good. So what we have here is the result of our merge. So it literally merged the files in together. If we open it up in VC Talk Other, we can see that we got the comment from here as well. Now we don't have it here because we haven't pushed this yet. We haven't pulled here. But this is the result of the merge. It kept the changes that we made, and it pulled in the other changes that happened upstream. And that's what this looks like. So when a merge happens, it actually creates a whole other branch to combine the two files together. So that's why it's represented this way. So now we can go ahead and push. And it looks like we have two commits to push up. Not just the commit that we did, but also the commit involving the merge. So we can push that up. And now, let's check it out on the website as well. So now if we look at it on Bitbucket, load the commits, we can see a very similar representation where these commits were merged because we had changed the same file there. And now if we come back to VC Talk, this already recognizes that there's two things that need to get pulled in. Let's go ahead and do that. And should be good. Histories look the same. Same to me. And the files, files look the same as well. Alright, so that is simple merging. Now we didn't talk about setting up a merge tool yet. We're definitely going to need that in the next section. SourceTree doesn't come with any merge tools, but these are a number of them that you can use. Personally, my preference is Tortoise Merge. I'm not going to officially recommend it here because it's a little difficult to find without installing Tortoise SVN or Tortoise Git, and you can look those up in your spare time if you're interested. But I used to have Tortoise SVN installed on my computer years ago, and I already had Tortoise Merge, and it's a merge tool that I'm used to, so I'm able to use that with Git. For the purpose of this tutorial, though, I recommend using P4 Merge, which is the merge tool that comes with Perforce, and that's much easier to find as a standalone tool. So, P4 Merge, download, go ahead and Google that, and it comes right up. And you can go ahead and download and install this if you want. If you want to get the, if you do want to get Tortoise Merge, you actually, without installing, Tortoise SVN or Tortoise Git, you actually have to you have to find it on SourceForge, and there's an old build of it, and I don't know, it's a little bit tricky. But if you can figure it out on Google, then good for you. I'm a fan of Tortoise Merge, but P4 Merge is a great tool as well. Now let's talk about conflicts. So conflicts are what happens when an automatic merge fails. Git is not able to just resolve the differences between different branches of our project, and we're going to have to get in there and resolve it manually. So there's pretty much two types of conflicts you'll run into. There's edit versus edit, and there is edit versus delete. So before I dive into conflicts, I just want to point out how you would go about installing a merge tool. So, go ahead and download and install P4Merge, and then in source tree, go to Tools, Options, and then next to Diff, you could choose your external diff tool as well as your merge tool. So it has some popular ones right here, kdiff3, diff merge, tortoise merge. So go ahead and pick it. It'll ask you to find it in your file system, and you just go ahead and point it at the executable wherever you installed it. And then these will be your go-to tools for external diffing and merging. Alright, so let's go ahead and create a conflict. This will be a conflict. Indeed. Alright, so let's go ahead and commit both of these. Okay. Set up a conflict in a script. Alright. Other half of conflict. Alrighty, so let's go ahead and push this. Alright, so if we look, you can see the other half of the conflict is up. Well, let's go ahead, and we know we're not going to be able to push this. We can try, but it's going to complain because we haven't pulled yet. So it's going to get mad at us here. So now this could be a good situation to fetch if we were working with other people. We could fetch, see that we have something to pull in, take a look at it, and then if we notice, oh dear, it looks like they've changed the same file that we have, and it looks like the same line as well. This would be a good time to grab your teammate or shoot them a message on Skype or Slack or whatever you're using and let them know, hey, there's about to be a merge conflict. Maybe we can talk through what's going to happen. That is if you don't think you can figure it out on your own. Let's go ahead and pull this in. Alright, so we have a conflict. Auto merging did not succeed. So let's go ahead and close that. And we can see in the bookmarks area that we're in the middle of a merge now. So let's go to our working copy. And now we are merging the edit file. So if we take a look at the diffs, what we have here are merge markers. And these are pretty standard to any version control software. They have this kind of format with the less than signs and the greater than signs. So head, again, refers to the current version of our project that's checked out, and then this hash refers to the commit that we're trying to merge with. So F8 56 whatever, that is going to be the latest commit that was just pushed, which is the other half of the conflict here. So there's a couple ways we can resolve this merge. This one's pretty simple. One thing we can do is just to right-click on the conflicted file. Its icon is for conflict. And we can just choose to resolve it by using either mine or theirs. So in this case, let's say we resolve it by using theirs. We'll just take whatever edit that they made. So that's easy enough. This has our diff here. So that looks pretty good, but we're not done yet. We still need to commit before we have confirmed this merge. So whenever you do run into a merge conflict, you're going to have some information auto-populated into your commit message. Go ahead and leave that. And we'll just describe what we did to resolve the merge. Chose theirs. Commented. Indeed. Alright. Now that that's been resolved, we can see that the status is no longer merge over here. If we take a look at our history, we can see that we're ahead of origin master now. In our description for the commit, we see that we have some stuff populated there because this message is a little longer than it typically has been. So we can go ahead and push this up. The merge has been resolved. It's all good. We can pull it down in the other repo. And we're not going to get a conflict here because the conflict was already resolved in the other repository. So we've told the remote that, hey, everything's good. This is how things should be. And we decided to choose theirs. So really, for this one, nothing's changing. This is what happened during that merge, but this is just what we added here in the first place. So if we come back, we can see that this on the left is going to change to indeed, but on the right it didn't, because this is where we experienced the conflict. Okay, let's do that again. This time, let's do another type of resolution. Let's say, I'll add another line. This will be an X. This will be resolved externally. This will be resolved. Alright, so similar situation here. I'm actually going to change something else. Comment and start. Add an exclamation point there. And I will add a question mark here. Just to show that all the diffs are going to get merged, but not everyone is going to produce a conflict. Okay. Go ahead and let this refresh. Oh, that's in VC other. Let's come to VC talk first. Even though both of these should have some diffs. Alright. About to see another conflict. And go ahead and push this up right away. So this one is clean on this end. There we go. Another half of second conflict. This time we know that we can't push because it'll get mad. We know that if we fetch, it'll be different upstream. So let's just go ahead and pull and then deal with it. Alright, so again, problem with auto merging, conflict. Let's see what the issue is. So now this is the conflicted area, but we don't necessarily just want to choose mine or theirs, because there's some other changes that we made to this file and we don't want to throw away our changes. So in this case, let's launch an external merge tool. Alright, and now source tree is reminding us that we're going to want to quit the merge tool after we're done using it. So this is p4 merge. Before I show how to use this, I just want to go back real quick and point out these conflict files. Now these are automatically generated by the merge tool, and they are what allow us to do this merge. So each of these is a version of this file in a various state. So this is a backup of it, in case we edit it. The base is the local, the base is the common ancestor of the two files. The local is our local one, the remote is the remote one. So it just creates all these files locally. And that is to say that if you abort your merge and you have a bunch of files like this hanging out, make sure you delete them. You don't want these files in your repository. Some version control tools are good about deleting them automatically, but sometimes things fall through the cracks and they end up in your unstaged area. So if you see files that look like this in your repo and you're positive that you didn't add them, go ahead and delete them because you don't want them to be tracked. Alright, so this is P4 merge. So again, the base is the common ancestor of the two files. It's the last version of it that the two of them had in common. Local is our version of it. This is what we did. We added this exclamation point. We changed this line here. Remote, this is how it changed upstream. This line didn't change, but they added a question mark here, and they changed this line this way. So down here, these are the proposed changes to the file. Now, it still has the change up here because there's no conflict there. So that's good, that's in blue. It has it has a few things going on here. I suppose there are a lot of lines I changed. Okay, so indeed, the question mark there is in green, but this whole area is in conflict, though. That's what the red is about. It's not really sure what we want to do here. Now, with these navigation tools, what we can do is we can go back and forth between the various diffs in our merge, and with the reds we can go directly to the conflicts. Right now there's only really the one conflict, and that's this whole area here. And what else do we have? Show line numbers, that's always helpful. Inline differences, so I suppose if we didn't have that we wouldn't see things like the exclamation point pointed out. Comparison method, I like this comparison method. So what we're going to want to do is we're going to want to change the file and then save it. Then that'll be the final version of the file that we want to keep. Here we can choose different versions that we want. So for example, we can choose the base version, which doesn't have any modification to it. We can just get rid of the line altogether. And we can choose the local version, which had the exclamation point. Let's go ahead and do that. And here we can do something similar. We can choose the base version, which is just indeed. We can choose the local version, which has the bottom line changing that way. Or we can choose the remote version, which has the question mark and the second line changing in that way as well. We can do combinations by holding shift. That's what these look like. So, we have some different choices in terms of merging the files. And frankly, we can also just do something manually. So, let's say, get rid of this. Indeed, period. Externally by P4 merge. Alright, so we can resolve it however we want, frankly. And if we don't like how we've changed it so far, we can, go back and reset it to how it was. But in this case, solve by P4 merge. Winky face this time. Alright, so that looks good. Then we go ahead and save that, or click that up there. I hit Control S. So once this is saved and we're happy with the file, just go ahead and close this. So it recognizes that we're done merging. So it got rid of all of those temp files. It says that we're still in a merge state here. We can look at the diffs for the file. If they don't pop up immediately, again, you can sometimes it helps to just change one of the filters. So this is the line we added here, because compared to how this was before, this is the only thing that really changed. And now we make sure that we commit. You always need to commit to resolve the merge. Let's see, manually resolved merge with P4 merge. And we're going to commit. Alright. So now we are good to go on that front. Go ahead and push that up. And then we can pull it down on the other side. It's all green. And if we look at both scripts, they're both going to have the same stuff, because they all got resolved. Alright, now let's do another one. This time we're going to do two things this time. We're going to do a edit versus delete. Alright. So yeah, those are edit versus edits, and this happens when the same line are changed in the same file. You know, we saw the conflict markers. We can choose mine or theirs to settle right away, explain the conflict files. Oh, also, alright, so before we do the edit versus delete, let me show you reset all. I mentioned earlier that it will reset merge data. So let's have a look at that. Gonna reset this. That will be necessary. Alright. And both of these are saved. Okay. Added comment for conflict. So, I'm gonna push this one first, but it doesn't really matter. To demo reset all from conflict. Alright. Go ahead and push this up. Alright, rad. So now, I wanted to pull. And we get that conflict again. So now we're in a conflict state. Now the thing about a conflict state is that it has to be resolved. You can't do anything else while you're in this conflicted state. So let's say that we pulled this in and we're not really sure what to do. We can't even really continue working. You know, like let's say we wanted to edit some other file in our project, like, you know, gonna add. You want to reload it? Yeah, sure. So these are conflict markers. Gonna add, this is actually on this side. Oh, whoops. No, let's kind of edit this here. Gonna add, right? Because these are both VC talk, and this is VC talk other. So gonna add, let's see, hard to work during a conflict. All right. Let's see if this pops up. Go ahead and have this. Let's stage this. But this conflict is still staged. Can we unstage it? Alright, so gonna edit is down here. It still has a conflicted status. Let's see. So now, if we do this commit, it's gonna think we're resolving the merge, but we actually haven't. And it's really important that you don't commit unless you're actually resolving a merge, because if you do, then you're going to push the file with these merge markers in them, and then this is definitely not going to compile. But also, if the merge markers are gone, then it's going to be difficult for you to launch the merge tool automatically. You're going to have to figure out how to do that manually, or you're just going to have to look at the file and merge it yourself. These files are a little simpler because there's just one line where they're conflicting really, but there could be a bunch of places, especially if multiple people are working in the same file. So in this case, we got into sort of a weird situation, and we want to back out. So let's go ahead and discard. But not just discard everything, let's do a reset all. So, matter of fact, this will be neat. What I'm going to do is I'm going to go ahead and stash this change. Well, is it going to... No, I think it'll stash my unchanged file too, so let me not do that. Well, let's try it. Stash. Stash during conflict. Let's see what happens here. Okay, so that stashed everything. Interesting. And it kept this this merge message here, so I just deleted that. But we're still not up to date. I still have to pull in. And if I do that, I'm still going to get this conflict, because it never got resolved, frankly. So I still can't push or anything, even though I stashed that change that I made to my gonna add file. And now I'm in a totally weird state. So I had this change to gonna add, but let's see what happens if I try to apply this. Ugh. No, unable to refresh the index, so because gonna edit needs a merge, so things are all kinds of strange now. Alright, well, now let's go ahead and do a reset all. So reset all also reset my merge data, which is what I was looking for. So now it's going to be okay for me to just do regular commits without worrying about resolving a commit by accident. So now what I did here, I'm going to delete this stash, so I don't want it anymore, is I reapplied the stash, but this isn't from the actual merge. These are just the changes that I had. Now I wasn't sure if it was going to also stash my unstaged file, and it did. So that's something to be mindful of. Even if you have an edit, even if it's not staged, it's going to be stashed. So what I could do now in theory is I could discard this, because that was a diff from a merge that hasn't actually happened, and I could just commit this file here. So let me go ahead and do that. Made change to file during conflict, stashed, and did reset all, and discarded merged file diffs. So I can go ahead and do that. I still can't push, of course, because I'd have to pull first. I've got two things to push now, but it's going to get mad at me because I still haven't done the merge. But I just wanted to demonstrate that by doing reset all, you can eliminate the merge data. So you can still work locally. If you're not quite ready to merge yet, do a reset all to get rid of the merge data, because you don't want to commit a merge unless the merge is actually resolved. Because I've definitely seen that before, where people don't know what they're doing. They just choose commit anyway, and then they have files with these weird markers in them, and then it's kind of hard to resolve them. Or if you have those other files that say, backup and local and remote and all that junk, and we just don't want to deal with that. So if you want to bail on a merge, then just choose reset all. If you need some help, ask someone for some help. But make sure you only commit a merge when the merge is actually resolved. Let's go ahead and resolve this one externally as well. Let's see, and we really didn't do much here. But you know what? Let's just Let's just take them both. Yeah, just like that. Alright. Yeah, so just took both lines. And the important thing is that we did it through the merge tool, so that told Git that everything is cool. So it just got rid of the merge markers for us, it got rid of all those extra files, and now we can just commit it. Took both comments. Alright, so now we have quite a few things in our history. You know, added the comment, demo stuff, we made that we made that little change during the merge conflict because we wanted to avoid it doing a reset all. But now everything's cool. We can go ahead and push it up. On the other end, go ahead and pull it down. And gonna look good on both ends. Just gonna get both comments there. It changed both times because it had been saved before with the merge conflicts, but this is the most recent version of the file. Alright, that is reset all. Alright, now let's do an edit versus delete. Now the thing about edit versus delete is that it's not going to let you choose mine or theirs for a deleted file. So again, here it's really important to to communicate with your collaborators. So if you're going to go with the delete, then you need to make sure you commit after you remove the file and then push right afterwards. So let's go ahead and do that. Okay. This file is going away. So that's going to edit. Just get rid of it there. Come back to source tree. Open it up in the other location here. This is going to edit. Get rid of it and its meta file in VC Talk Other. Alright. So this is the diff we made. Testing, edit versus deletes conflict. I'm going to push this one up instead. Alright. Deleting file for, that's wrong, you're right, for conflict. So go ahead and push this. Alright, so now I'll come to VC Talk and we'll pull. Definitely going to get a problem here. Alright, so it's the problem. Removing this file, conflict, because we've edited it. So let's take a look at the issue we have now. So here we can see that what happened upstream is that the meta file was deleted, and then this file was deleted as well. So that's why it's empty. That's what the diff shows. This is what it wants to do, is just erase it. But what we did locally is that we added, we changed the line on it. So we're not really having any diffs here. And this can be pretty unintuitive when you just look at it. And also here, this isn't something that we're just going to be able to choose theirs for, because in this case, theirs doesn't actually exist. So if we wanted to choose theirs, what we'd have to do is delete the file. If we wanted to choose ours, then I think we can just go with choose mine, right? Which doesn't actually produce a difference in the local repository. Now this is important. So what we did is when we pulled in, what happened is we got the difference from, actually, here I can show it over again. I'm going to reset everything in this merge because nothing's been completed yet. Alright. So this is our file system for this project. Let's go ahead and do a poll again. Again, that's why reset all is pretty useful, because it'll bail you out of a merge. Alright, so now we can look at these diffs and we see that there's a conflict in gonna edit. So here, yeah, let's reload it. So here it looks pretty much the same on our file system, but this wants to get rid of it, and now we're not really sure what to do, because upstream this file is gone. And if we wanted to understand that, it would help to look at the history and see what happened. Scroll up here. In the latest version of Origin Master, it's like, okay, this file's been deleted. That's what the problem is. So now in our working copy, if we wanted to be even with Origin Master, then we would have to delete this file locally as well. If we wanted to keep this file, then all we would have to do is discard these changes, and then we could say that, you know what, we're not going to delete this file. So first let's do an example of that. What I will do is I will discard the changes, but I will not do reset all. That will not reset the merged data, right? So we're still in a merge, but I also still have both of these files. So that's effectively like choosing mine, because I decided not to delete the files. Decided to keep files in edit versus delete conflict. Okay. So I'll commit that. Right. Go ahead and push that up. Okay. So in the last commit, nothing happened locally. But if we look at it on, Bitbucket, just refresh this. This was the last merge we did. Decided to keep the files. And we can see that the files are still there, right? Even though it doesn't say that they were added in this commit, because we were in a conflict, the state of the repository at the end of the conflict is going to be the state of the repository that is in the history. So the diffs in a conflict aren't always completely reliable in regards of what happened. Like if we look here, in the previous commit, these two files were deleted. In the next commit, the files weren't added, and yet the files still exist. And that is because we were in a conflict and we had to resolve things manually. So again, the important thing to remember about a conflict is communicate, communicate, communicate. Now let's do this again, but this time we're going to delete the files. It's going away now. All right. So say last edit before conflict. And I'll push this one up. It's all good. Now here, I'll delete this one in source tree by going to clean to show things in my repo. And now, oh, whoops, I gotta, right, because this had been deleted, but this one hasn't been updated yet. That's why gonna edit isn't there anymore. Let's go ahead and pull this in. Pull those changes. Right, and now these files are back because we saved them in the conflict. So we see them in the file system there. Alright, so now we select these, choose remove, go to our working copy, check out pending. Alright, deleting these files yet again. Alright, and now Let's go ahead and pull. Okay. Let's edit for conflict. Origin master. Do these files yet again. Did I pull these in? Oh, did I edit the wrong file? Did I delete? Can I edit? Origin master. This is edited. And here this got deleted. Oh, I did the order of operations wrong. Okay, that's fine. So I can still push these up. Okay, so I think the reason that worked was because in the timeline, I had still edited these files before they had been committed. So it wasn't like something had happened to files that had already been deleted. Now this time, these files have been deleted at 2007. So before I go ahead and pull, I'm going to edit this again. Now, all right. Conflict this time. Alright, now I've edited these files clearly after they've been deleted and pushed in the central repo. So if I go to pull this in, alright, I get the conflict I was expecting. And now to resolve it, rather than keeping these files around, I will just have them both just choose remove. Remove you. Right. So that was the local version of the file. So now, it's just these deletes that are going to happen. Accepting deletion of files in conflict. Alrighty. I can push this up. And we're good. Accepting deletion. This one, get synced up. But the latest stuff should already be up there as well. Scroll up there. And good. Alright. That is conflicts. Oh, before I forget, there's also what I'm going to call an idea of invisible conflicts. And that is just to remind you guys that Git is just going to merge your files, but it doesn't know how your game is supposed to work or feel, or even how the project's supposed to build. So just because files merge successfully doesn't mean that whatever Git did was the desired result. So definitely don't over-rely on just these technical tools, and make sure that you're always aware of what's going on with your project. These things are here to help you, but they're not perfect. So now let's talk about branching. So branches are separate histories in our repositories. So by default, the main branch that we deal with is called master, but we can create our own branches and not just have to, deal with the branches that are created whenever we have a merge conflict or something like that. Branches are great for experimenting because, again, they're whole separate histories of our project where we can do anything that we want, and it doesn't have to affect the main line or any other line of development. And we can have local branches as well as remote branches, and really branches are meant to be merged. So let's come back to Unity. I haven't been here in a little bit. It's compiling all our comments. And our scene should be a bunch of blue boxes, if I do recall. Red. So let's go ahead and make a branch. And we can do that by going ahead and clicking on this branch button. Let's call our branch Red Robot. We will copy the working tree parent. You can also branch off a specific commit if there's a certain, if there's a certain point in time which you wanted to branch off, and it's not just the current one. So again, very powerful in allowing us to experiment with stuff. And we're going to check out this new branch, because just because we make a branch doesn't mean we want to be working on it necessarily. And check out just pretty much means choose. So right now we have the master branch checked out. It's the only branch we have. So we're going to make this Red Robot branch, and we're also going to check it out. Alright, so now this is everything that we've got here. We've got Red Robot, we've got Origin Master, we have Master, and all of these are in sync right now. All of these have pretty much the same history. But now let's take Red Robot and diverge it a little bit. Mainly by making our robot red. Alright. Not only red, let's make it a little bigger too. Alright. Make sure our scene got saved. There's no changes in the scene file itself. Alright. So, now we're committing to the Red Robot branch. And robot red and bigger. So now, if we take a look at our history, we can see that our branch is ahead of the other lines. But nothing has been committed yet in Master or Origin Master, so these are pretty much still the main line of development. And if we wanted to merge these, it would just kind of be a fast forward. But let's do something different here. Let's commit something in the other branch that's still in Master. It can be something completely arbitrary. How about change color changer? Doesn't exist. Just keep other scripts on the right side. This is a comment. Print color changer ready. Alright. Come back to source tree. Alright. Go ahead and commit that print statement. Changer script. Alrighty, now let's go ahead and push that up. So something that's interesting here is that this repo is not aware of the Red Robot branch because it hasn't been published yet. So this branch currently is just a local branch. It's not a remote branch. We don't see it up here under the origin. We'd have to publish it if we wanted to do that. And by that I just mean push. But as far as this thing is concerned, all we've got are Master, Origin Master, and Origin Head, which are just, pretty much the most recent point of Origin Master. But on this side, if we look at our history, and then we fetch, we're going to see that there's been a bit of a branch, or a bit of a split. Alright, so now Origin Master is up here. So this is where the latest version of the repo is. Now this is Red Robot, this is the branch that we're on, and this is our local version of Master, and this is one behind. So already, just with two branches, this can seem pretty complicated. But the important concepts to remember are local versus remote, and the idea of tracking. So our Master branch tracks the Origin Master branch. And this is our local version of it, and this is the remote version of it. Remember, the remotes always have the name of the remote, followed by a slash, and then the branch name. So our local Master branch, which is tracking Origin Master, is one commit behind it. So this one could do a pull to be brought up to date. Red Robot isn't tracking any branch, so it's just sort of off on its own. Let's go ahead and publish Red Robot though, just to get it up there. So now it's saying, well, which branches do we want to push? Let's go ahead and push Red Robot, and it's going to create a remote branch of the same name. Alright, so it's all green. Let's take a look at it on the Bitbucket website. Let's refresh this here. And oh, okay, so it's just showing the master branch. Let's go ahead and show them all. And we have a couple branches now. So this is the Red Robot branch. By default, it shows master, because again, master is the default branch. But this is what our history looks like. So we could keep developing on master, we could keep developing on Red Robot, and they'll continue to be diverged. We could have even more branches going on, like these can get very, very intricate, and eventually they can get merged together. So let's go ahead and just bring these in. Oh, but also, now on this side, now that Red Robot is published, we can go ahead and do a fetch to get the latest info from upstream. And now we see that there's this remote branch called Red Robot, and that's origin Red Robot, and that's back here. And it's like, okay, so someone made a branch that's been published. That's not what I'm doing, that's some other stuff, but that's cool. Now, if we decided that we would like to merge with this branch, we can just select it. Check out Red Robot. Okay, so if we wanted it locally here, to locally check out a remote branch, we could check out origin Red Robot. This should be our local branch name, which should be Red Robot. Okay, so now we have a local Red Robot branch, and if we wanted to, we could merge master into the Red Robot branch. Oh, which should be interesting, because what we did in master is we made the color changer script print this statement. So let's go ahead and do that actually. We'll merge master into the current branch. Are you sure you want to do this? Yeah, let's do it. So now this is what we've got here. We're on the Red Robot branch that's been combined with master. Go ahead and push that up. Push up the Red Robot branch. And now we will go to the original project here, where we first created Red Robot. We will fetch from upstream just to see what changes have been going on. And now we can see that ahead of us, origin Red Robot is ahead of us. So let's go ahead and pull that in. And we're still behind in origin master, so let's just get everything. We can pull remote branch to pull. So right now it looks like it's just going to pull the Red Robot branch. It might sync everything, but let's see. Alright, so now Red Robot is up to date. We have this print statement here. The master branch is still behind, so looks like it's not going to pull everything automatically. If we want to be completely up to date, we're going to need to sync all of the branches individually. So now, when behind, we pulled the master branch. Oh, but I guess we're not really going to see it unless we check it out. We don't want to do that just yet. So that's fine. So Red Robot is in sync with origin Red Robot. Come back to Unity. Take a look at our Red Robot. If we play it, we can see that print statement. Color changer ready, which actually fired 4 times for our 4 boxes. So it's neat. So that's the Red Robot branch where we're just trying different stuff out. And at any point we can go back to master. Let's check that out. Check out master. Let's see, just want to make sure I clicked it and didn't miss anything. That one's got as well. No, it's still got Red Robot. Check out master. Alright, cool. Alright, now we're on master again. And we can sync this by we're one commit behind origin master. So let's pull in the master remote branch. Now we are all up to date here. Alright, now red robot. Main robot, red and bigger. Alright, great. So now we're back on the, still got the old changes. Now we're back on the regular master branch, which still has, the print statement, but it doesn't have the red robots, because that's something that we did on another branch. So we just want to toggle remote branches there, make it a little easier to look at. Made robot, red and bigger. So this is something that happened on the red robot branch. Oh, I see. Oh, it's funny. I assumed that the red robot branch was going to be the red branch, but it's actually the blue branch. So yeah, this is something that happened on another branch, making the robot red and bigger. But the branch we're on, master, this pink one, doesn't have this point in the history. So again, this is just another way that Git lets us experiment with things and try things out and track things in a very, very nuanced way. So that is branching. It's pretty powerful. And, have fun with it. Remember, branches are meant to be merged. And if you get into a conflict, there's all kinds of ways you can resolve it. You can choose mine or theirs if it's an edit versus edit conflict. If it's an edit versus delete conflict, make sure you communicate with your teammate to know whether or not that file really needs to be there. And you can always launch an external diff tool to resolve the merge as well, if there's a conflict. So these are some other topics that I didn't cover, but I'll just speak about them briefly, and you can go look them up on your own if you're interested. So there's tags. Tags are similar to branches, except that the idea with the tag is that it's more like you want to mark a version of your project in history to refer back to. Tags aren't really meant to be worked on. Tags are more like releases. So, for example, let's say we were working on our game and we were coming up to the version 1.0 release. Then what we could do is make a branch for version 1.0 and then make a tag at version 1.0 as well. We could submit version 1.0 to the App Store or to Steam or whatever. And then if we have to make any updates to that specific version of the game, we would check out the version 1.0 branch, make the changes there, and then create a new tag for every release. Meanwhile, the main line of development for which we're working on, version 2.0 or 3.0 or whatever, would still be master or whatever it's called. But we wouldn't be working on that for updates we would make to the released version of the game, if that makes sense. That's the scenario that I've definitely been in. Now, Git LFS. Again, I said in the beginning that Git is optimized for text files, and it's not really great at binary files, especially large binary files. Now, some of the hosting providers that we're using are going to complain if your files are too large. Definitely Bitbucket will if your file is larger than, I believe, 10 megs. And in GitHub, I don't believe that by default it will even accept an upload of anything larger than 100 megs. And a way that a lot of people have worked around this is by using this system called GitLFS, which comes bundled into SourceTree. And the way that works is you want to go over to repository, GitLFS, and then initialize your repository. And you need to do that first just to make sure your repository is ready to use GitLFS. It just runs a simple command line argument. And then the way that you use it is you add certain file types that are known to be particularly large. So, you could definitely add WAV files. You could add, PSD files if you have Photoshop files. You can also create your own custom paths. It doesn't have to be just file types. It can be folders and stuff as well. Say we want FLV files, so track these files. And if we take a look at the diffs here, what it does is it creates this .getAttributes file. And then this is the pattern it has for filtering files out. So this is the ignore pattern, or rather the LFS pattern. This is the filter we're using, and then this is some information for how it's going to handle diffs and merges. So if we wanted to include a folder called sound in here, for example, we would just add a line here and call it sound. By default, SourceTree allows us to add file types, but it doesn't seem like there's a way to add just specific types of files. Unless I can type in here. Could I? Sound clips. No, because it thinks it's a file type. So again, if you wanted to add a folder in there, you could just add that manually. It doesn't just have to be file types. And the way GitLFS works is it replaces your large binary file with a small text file that actually has a pointer to that location, to the location of the file, which is actually hosted on a remote server somewhere else. So rather than keeping different versions of 50 and 100 and 200 megabyte files in your file system somewhere, it just hosts them up on a server. Then actually when you need them, it'll fetch them on demand. And that helps save a lot of time when you're doing things like cloning and pushing, because it doesn't have to push quite so much data. So definitely I recommend GitLFS. I recommend using it early in your project because it can be a problem if you commit large files early on and then you want to use GitLFS later. The thing is, in the earlier commit, you already had the large version of the file, so it's already in the history. So you definitely want to head that off at the pass by first using GitLFS before you add anything too big to your repo. There's also rebasing. Rebasing is a really powerful and really advanced Git feature, and it can help you do a number of things. And one of them is to rewrite your history. So let's say, for example, we wanted to get rid of a couple commits, or we wanted to reorder some commits, or we wanted to change some commits. Like in this one, we wanted to change the message, or in this one, we decided we wanted to delete another file as well, or we just, we just didn't want this commit to, well, that's a merge conflict, or we just didn't want this commit to happen at all. You can do all those kinds of things with rebasing. SourceTree has an interactive rebase tool. I just want to advise that you need to be very careful with rebasing, especially if you're using a public repository, because what rebasing does is it creates a separate history with different commit IDs for everything that gets rebased. And that can be an issue if your repo is shared publicly, because then if someone tries to pull from it, their history is going to be really mixed up because the commit IDs are different. So that can lead to like real headaches and real difficulties merging and just diffing and just knowing what the heck happened when in your repo. So if you're going to be rebasing, well, first read about it and find out what the heck you're doing. But the good rule of thumb is that it's best to rebase locally and before you push anything. Because if other people are basing their work off your rebased work, you guys definitely need to be on the same page. They might be better off just cloning a new repo than trying to merge in the changes that you've done. And I didn't go over it because it's so advanced. And then finally we have filter branch and the BFG tool. So filter branch is another way of rewriting history that's pretty extreme. It's stronger, not extreme, but it's pretty powerful. So you need to know what you're doing. It can go even further than the rebase tool. And I specify the BFG tool as well, because that is really designed to address a specific problem. Here, I'll look it up actually. And that problem is the one I was mentioning before, where you add a really large file to your Git repo, and you want to get rid of it, but it's a few points back in your history. And the thing is, you can't just enable LFS because that large file is still in the history somewhere, and you can't go back and change the history unless you do something like a rebase or a filter branch. And that's what the BFG repo cleaner was created for. I've done some tests with it, and it's interesting. I couldn't wrap my head around it enough to go ahead and provide an example for this. The one time I had to help someone do this in a game jam, I actually used filter branch instead. The BFG tool is meant to be a lot simpler than filter branch. I think that's even one of its tags, an alternative to filter branch, because that can be a pretty intense piece of command line foo that you're writing. But if you do find yourself in this problem where you've been working on a project for a while and you have a Git history that you don't want to lose, and somewhere early on you committed a 100 megabyte file and you try to push it to GitHub, and GitHub just won't let you push any of your changes because you have this giant file in there and you're not really sure what to do, I would recommend checking out the BFG tool and filter branch. The BFG tool is supposed to be a lot simpler, but again, I believe that after you use it, it's going to change the IDs for your commits. So let your teammates know about that if they're going to need to rebase or if they're going to need to clone a new project or something. That's something to be mindful of. This is pretty advanced Git stuff, so I just wanted to let you guys know about it in case you run into these issues. But otherwise, that is pretty much it. We got a pretty rich history here. LFS, I'm not going to commit that stuff. So, hope this was good, and yeah, go version control all the things.